Hello everyone, my name is Joris Peels, and this is another edition of 3D Printing News Unpeeled. And today we're going to be looking at some actually potentially really very big developments. So first one is emission directionality of 3D printed photonic nanowires. So this was a paper. It was published in ACS Nano. It's by Yongchen Bei, Chanbin Yu, Sungyun Yoon, and a whole bunch of other people. And they're from the Korea Electrotechnology Research Institute, better known as KERI. Now, these guys have been doing tons of work on displays generally, nano printing, and making nanowires and all that kind of thing for a really long time now. And now they've tried to shrink these light emitting devices to make some of the smallest light emitting devices we can make. And what they've found is that by varying the nozzle control, by actually trying to opening and closing the nozzle when they're printing these nano temperatures or nano sizes, what they can do is they can make a 300 nanometer diameter kind of nanowire that has directional light emission. And directional light emission means that you can direct that light in ways, and they can now coherently print this in ways that it could be used maybe from quantum, but probably the application they're going for is for computer screens, displays generally, a new display technology. And this could be, they also say that this is quite a low cost technology as well. Now, this is very far away from being the screen of your new laptop. But it does mean that there could be a new technology that replaces OLED and all the other things with 3D printing. That could be that all of a sudden the most high volume 3D printing application in the world could be computer screens. So I think this is a wonderful development. Of course, we don't know if this is going to work at scale, and it may work at scale, but then it'd be like 1 cent more expensive than other technology, and that would win out. So we don't know yet, but I think this is a really exciting kind of development anyway so far. The other thing is this represents, I think, a mountain of papers that are headed for us at the moment. So this is the paper is real-time precision in 3D concrete printing, controlling layer morphology via machine vision and learning algorithms. This is by a bunch of people: João Silva, Gabriel Wagner, Rafael Silva. They're working from the Built CoLab, the Collaborative Laboratory for the Future Built Environment in Porto, and the University of Minho, which is in Guimarães. And that is both in Portugal. They published this in a paper thing called Inventions, and they're essentially looking at machine learning and construction 3D printing. Now, I think this is fantastic. I expect us to have hundreds of papers like this at one point. And what they're doing essentially is they've looked at speed control. They've looked at saying, okay, so if we can adjust the motion of the robot and the material flow rate, we can then get the layer width correct. Can we develop a data set and develop a bunch of machine learning algorithms and machine computer vision algorithms and kind of a monitoring tool so that we could automatically kind of generate, track, predict this layer width? And if we get, of course, the same layer width, then we can better control this process. They were successful. They've trained their own data set. They could predict the speed based on just this layer width with about 87% precision. Not great, but hey, we're getting there. They do point out that if they change the concrete mix, they'll need a completely new data set. So, you may not be able to just machine learn your way out of this very easily. It'll take a lot of testing, a lot of different data sets, a lot of different mixes, a lot of different setups for you to be able to do this. What they can do now is they also have created a kind of print monitoring system, quite a simple setup really, to monitor these prints. I think this is an absolutely fantastic product. Just this, of course, everybody's going to say, oh my God, machine learning and construction 3D printing, it's just like, two hype things together. Let's make something amazing out of this. But at the same time, just a simple monitoring setup that'll monitor this layer with consistently and be able to predict it. That would be a huge, benefit to, AI build or a DAXIS or somebody who just wants to, develop a simple set of cameras to monitor construction 3D printing. I would love that if I was going to build a bridge or something that tens of thousands of cars would drive over it. I would love to be able to, at least know how thick my layers are and at least how, try to estimate what my layer bonding would be. So I think that, this is a great paper, and I would expect a lot more of this machine learning, machine vision for better 3D printing, finding settings, that kind of stuff. I expect a lot more of that to happen. And the next thing is from ToyBox. ToyBox is the 3D printer for kids. It's the only one at the moment that's specifically designed for it. They've previously, they have a bit of a different model because they have licensed products. So they have license from Warner Brothers and Universal and Paramount, people like that. and they print then these licensed products, which of course makes these content owners very happy. And now they've partnered with magicians Penn and Teller to commercialize 5 printed home magic tricks. And yeah, this is a way of doing it. I would prefer for kids to make their own magic tricks. I would prefer for kids to use their own creativity, make their own Avengers, or make their own kind of princesses and things like that. But this model, you can see how this is a real big revenue stream for these content creation people. And hey, they can make, if they can keep making partners like this, they could really make this a very attractive proposition, kind of a Netflix for 3D printing kind of thing. Now, what's interesting is in this article, they kind of disclose some figures that kind of surprised me, actually. I didn't know. So they say they have 250,000 users on the platform, which could be true. And then they make 14.7 toys per month. So I don't know how they count toys, but that to me is a huge number, by the way. If we're looking at, Power 3D printing users, they print about, on average, 20 things a month. And other people are more around 5 to 10. So apparently these kids are around 14, and they also say they've printed 15 million toys since they launched in 2017, which is a bit weird if they have 250,000 users and they make 14.7 toys per month. It's a bit strange, that kind of calculation, unless they've been growing incredibly quickly very, very recently. But anyway, generally it's interesting to see that this is happening, and I think that if you want to get a company like Disney involved, kind of a captive Netflix kind of controlled environment, that's what it's going to take to get them involved. And maybe this is a revenue stream. This is a different way. Like I said, I would prefer for kids to just make their own characters, really, but in their own games and stuff like that, and really enable their creativity. I think this is kind of a canned creativity. But hey, this apparently is a much bigger thing than I think most of us maybe would have thought of. Anyway, my name's Joris Peels. This is another edition of